Hey everybody, this is Longo, and in this video we are going to cover polar complex numbers with the product and quotient, and we're also going to do some powers as well. It's a theorem called de Moivre's theorem. Now, fair warning, this looks scary, but it's just a lot of writing. That's all it is. It's not difficult, as long as you, of course, understand the unit circle. It's a very easy thing, and it's going to bring back some memories to other things that we've done, specifically with exponents and logs. So don't let this scare you. It's just a lot of writing, because it's not like writing 2x plus 2y. We're writing cosine and sine over and over and over. So when you are working with complex numbers, it's going to have some similarities to the things that we've done in the past. So this just means R1, so this is one angle with a radius, and we're going to multiply it to another one. So that's what the R1 and theta 1 stands for. So this is just R cosine theta plus RI sine theta if you were to distribute. And then this is just the second angle. So this is just big, long, fancy writing for one angle times another angle when we are working with polar complex numbers. Again, remember, if we are in polar, we have a shortcut form, writing CIS instead of cosine theta plus I sine theta. Don't forget about that. So basically, if we are multiplying two angles, we're going to multiply their radii, but we are going to add the angles together. That's it. That's all this big crazy thing is saying. Multiply two angles, we're going to multiply the radii, but we're going to add the angles. That is as crazy as it looks, is all you have to do. So let's get to it. We're going to do one example in polar and one example in rectangular for all three of these. So polar, all we have to do is multiply the radii. So that's going to be 7 times 3. And then what we are going to do is add the angles. So this is going to be CIS of 7 pi over 12 plus pi over 12. Okay? And then we know that 7 times 3 is 21. CIS. And 7 plus 1 is 8 twelfths. 8 twelfths is going to reduce to 2 pi over 3. And we're done. That's it. That's how you do polar. It's that simple. It's just that it looked crazy, scary, not bad. Second one, we are still going to multiply the radii. So we have 7 times 5. But because we're in rectangular, we can't use the shortcut CIS. Here's why. This is going to give us cosine of 220 plus 5. So 225 plus I sine 220 plus 5 is 225. Okay? And because we are going to rectangular, we need our unit circle values for the cosine of 225. So remember, cosine of 225 is down here, reference angle of pi over 4. So 7 times 5 is 35. The cosine of 225 is a negative root 2 over 2. And then we have the sine of 225 is also a negative root 2 over 2. But this one has an I because that's our sine. Now we just have to distribute the 35. And because we cannot divide that evenly, that would be like negative 17.5 root 2. Or you can write it as 35 root 2 over 2. It's the same. So negative 17.5 root 2 minus 17.5 root 2 I. That's it. Game over. Again, you could write that as 35 over 2. So again, it's just a lot of writing, big, long, crazy formulas, but that's because, again, we're just writing a lot of letters for sine and cosine and all of that stuff. Quotient. Should also take you back to some of the things we did back in logs. Remember back in logs when we were multiplying, we added, when we were dividing, we subtracted. It's very, very similar. So the quotient is the exact same formula with this exception. When you are dividing, you are going to be subtracting the angles but dividing the radii, kind of like the last one. So instead of multiplying, you are dividing your radii, and instead of adding the angles, you're subtracting the angles. So polar, let's work with the shortcut. This is 12 divided by 4, and then CIS, and then the angle is 3 pi over 2 minus pi over 4. Now, of course, when you are subtracting fractions, you have to have a common denominator. So if you just change this to 6/4, 6 minus 1 is 5. So 12 divided by 4 is 3, CIS, and then our angle is 5 pi over 4. Done. Game over. Moving on to rectangular. Again, rectangular, you want to keep this in the long way because we are going to find our unit circle values. So when you are doing your first step, you're going to have 18 divided by 6. And now we are going to have cosine of 110 minus 20, which is 90 degrees, plus I sine of 110 minus 20 is 90 degrees. 18 divided by 6 last time I checked was 3. What is the cosine of 90? Remember, the cosine of 90 on the unit circle is 0. Plus, what is the sine of 90? The sine of 90 is 1, so this is 1i. And all we have to do is distribute this. 3 times 0 is 0, so our final answer is just 3i. That's it. That's it for doing the quotient. Last one is de Moivre's theorem, and that's the power. So if you remember back in the day, again, in logs, when you are raising something to a power, it was multiplication. Very similar here. So this one is basically saying, if you raise this to a power of n, then this is going to become, you raise the CIS to a power of n, and we're going to just raise the radius to that, and we're going to multiply it to the angle. Again, similar to what we've done in the past. So just check it out. This first example right here, what we are going to do is 3 to the 4th power. And then this is going to give us CIS of 4 times 40 degrees. Okay, so again, you raise the radius to the 4th power, and you multiply it to the angle. And 3 to the 4th power is 81. CIS. And then 4 times 40 is 160. And you're done. So again, similar things that you've done, it's just with trig. Last example. Got to keep it in long form because we're in rectangular. So what we are going to do here is raise 2 to the 5th power. And then we're going to have cosine of 5 times pi over 6, which is 5 pi over 6, plus I sine of 5 pi over 6. And from this part, though, we have to think about the unit circle again. So 2 to the 5th power is 32. The cosine of 5 pi over 6, remember, we're in quadrant 2, so that's where x is negative. So this is a negative root 3 over 2. And sine over there is a positive 1/2, so this is positive 1/2 I. And from there, you just distribute your 32. So 32 times a negative root 3 divided by 2 is a negative 16 root 3. And then we're just going to multiply 1/2 times 32, and that's going to give us 16i. And that's it, people. That's it for doing multiplying, dividing, and powers with complex numbers in the polar plane. This is Longo and I'm out. See you, bye.